Welcome to the subject Engineering Mechanics. Today we will see the topics equivalent force system and force couple system. Already we have studied what are the different types of the force systems, how to calculate the moments, application of Wagner's theorem, principle of moment. Whenever two forces are having the same resultant, means assume that there are two force systems acting on the bracket ABC, and in this force system we will consider two cases, case first and case second. Assume that force F1, F2, F3 is acting at bracket. Here force F4, F5, F6 is acting. Whenever object is under two different force systems, but the effect of both the force systems on the object is same, then we will say that force system acting in first case is equivalent to force system acting in second case. The two force systems are said to be equivalent to each other whenever the resultant of first force system is equal to resultant of second force system, not only in magnitude but also in direction. Means if we will calculate the resultant of this force system, assume it is at R1 and value is alpha 1, and we will calculate the resultant for case 2. Assume the resultant is R2 and magnitude is alpha 2. When the magnitude and direction of the resultant is same, magnitude and direction of the resultant is same, then we will consider both the force systems are equivalent to each other. But whenever a non-controlled force system is there, along with this R1 equal to R2, alpha 1 equal to alpha 2, we have to also consider the summation of moment about a point of first case should be equal to summation of moment about point of second. Means this moment center, this point to this point will be same in both the cases. If you will calculate the moment at A for case 1, then again we will calculate the moment for A in case 2 also. That moment also required to be same in magnitude and direction. So these are the three conditions. Actually we have only two conditions, R1 equal to R2 and summation of moment about a point of first force system must be equal to summation of moment about a point for second force system. But we know that the summation fx and summation fy, summation fx and summation fy are horizontal component and vertical component of the force system. That's why if resultant R1 is equal to resultant of second force system R2, therefore summation of fx of first must be equal to summation of fx of second, and summation of fy of first must be equal to summation of fy of second. Because we know that summation fx and summation fy are horizontal and vertical component of the resultant R. Also we know that summation fx equal to R cos alpha and summation fy equal to R sin alpha. It is a relationship between the horizontal component of resultant and algebraic sum of all the horizontal forces of the force system. Similarly for y, algebraic sum of vertical forces is equal to r sin alpha, which is vertical component of resultant. So there are three conditions now. Whenever two force systems are equivalent to each other, these three conditions must be valid. What is the first condition? First condition is, actually it is only two conditions, but this first condition we have considered in terms of summation of x of f of x and summation of f of y. That's why there are three conditions. The first condition is summation fx of first must be equal to summation of fx of second. Second condition, summation fy of first must be equal to summation fy of second. And third condition, moment of first force system about a particular point must be equal to the moment of second force system about the same point. Point will not change. Means if you are considering at point A, here also it must be at point A. If you are considering at C, then here in second case also it must be at point C. These are the three conditions. Whenever these three conditions are existing in between the two force systems, then those force systems are said to be equivalent to each other. Equivalent force system. Then how to determine the equivalent force system? If some force system is given, for example, this force system is given ABC, and in a statement they have asked that determine the equivalent force system consisting of a single force about point A. Then what we will do? We will use these three conditions of equivalent force system. Means this force system is given to us, and in second they have asked that obtain another force system in which only single force is acting at point A. Then first step is we will mark the given force system as first. It is the first force system. And it is the first force system. We will draw the desired force system which is required to find, and we will mark it as a second force system. Now we have two force systems. First force system which is given in problem statement. Second force system which we have to obtain. In second force system we don't know what is the magnitude of force which is acting at A, so we will consider as a F. What is the angle? We will consider it as a theta. Now the first force system and second force system is in front of you. How to obtain? Now what I will do? I will obtain the summation fx of first and summation fx of second. Very simple. For obtaining horizontal and vertical, I have to resolve. If it is angle theta 2 and it is angle theta 3, therefore f phi u cos theta 2, f phi u sin theta 2. Similarly, f6 sin theta 3 and f6 cos theta 3. I will write the summation fx of first. What is my conditions of equivalent force system? Summation of fx first of first force system is equal to summation of fx of second force system. In summation fx of first, f4 it is acting towards left. We know the sign convention. Rightward is positive, leftward is negative. Upward is positive, downward is negative. So f4 is leftward here, that's why it is negative. Then f phi u cos theta 2, it is rightward positive. f6 cos theta 3, it is also leftward equal to summation fx of second force system. This is the fx second force system. I will divide it into two components, f cos theta, f sin theta. Therefore, it is f cos theta. Similarly, I will write for second condition summation of fy of first is equal to summation of fy of second. F phi u sin theta 2. This force is downward minus and F6 sin theta 3. It is also downward plus, that is minus, and for equal to summation Fy of second force system, it has only one force, that is summation F sin theta. It is equation number 1. Equation number 2. Similarly, I will obtain the momentum about particular point for first force system. I will equate it to the moment about the same point of second. After obtaining this, F4 will be given in problem statement values. We have number of equations. We can easily solve that equation to determine the value of force F and theta. To obtain the equivalent force system, I will repeat the step. What is the first step? In first step, the given force system must be marked as a first and draw the desired force system which is required to obtain and mark it as second. That is first force system which is given in the problem statement. Second force system which is required to find. After drawing these two force systems, apply the condition of equivalent forces. We have three conditions of equivalent force system. First, summation Fx of first equal to summation of Fx of second. We will put the horizontal component of both the force systems. Then in second condition, summation Fy of first is equal to summation Fy of second. We will put the vertical component of the force systems. Then we will consider the moment of both the force system about the same point. And with the help of the equations obtained, we can easily solve the unknown which is required to find. So we will see numerical on this equivalent force system in next lecture. Now we will see the force coupled system. Force coupled system is a specific type of the equivalent force system in which the force system consists of a single force and a couple. A single force and a couple. As name, from its name we can understand that in this force system one force will be and one couple. The combination of the force system of force and couple, how to obtain? Very simple. Again I will consider the bracket. For example, this is the bracket of bracket. This force F couple yeah. This force system will be considered as a force couple system because it has single force and one couple yeah. How to obtain the force couple system? Once again, we will consider it from a very simple example. Consider at point A force F is active. And in problem statement, we have to obtain a force coupled system at point B. You have to obtain the force coupled system at point B. How to obtain? This point is point B point. Now listen here. We can understand how to obtain. It is point A, force F is acting. At point B, I will add two force which is parallel to force F, equal in magnitude but cancelling each other. There is no change in the force system because at point B both forces are cancelling each other. If the distance between point A and B is D, so for few minutes hide this force system, this force F1. Listen, this force F I will hide. Now the force system is F acting at A two forces separated by distance d forming a couple. We know that the definition, when two unlike parallel forces acting on the object separated by finite distance form a couple. Hide this force. These two forces are forming a couple. I will write here couple of magnitude F into D, and this force F will be as it is. At point. There is no change. There is no change in the force system. Means initially force F is acting at point A. We have transferred that force A along with the couple at point B. Very easy. Now how to obtain it? Whenever the force couple system is required to find at particular desired point, transfer the given single force. I will explain the steps to obtain the force couple system. Transfer the given single force to the desired point with same magnitude and direction. Transfer the given single force with same magnitude and direction to a desired point. In this case, my desired point is B. Very simple. Now I will not consider this figure. Just I will explain with the help of the steps. My desired point is D. I have to obtain the force couple system at point B. My first step is transfer the given single force to the desired point with same magnitude and direction. I will transfer this force F. This force is same magnitude and direction, and it is the distance between it. In second step, calculate the moment about point B for the given force and show it as a couple at point. If I am calculating the moment, what is the moment? Force into distance from the moment center. Force is F and distance from the moment center B is D. Therefore, the couple will have the magnitude of F into D. With orientation means from B the moment is in clockwise direction. Therefore, we will write it. Now the given force system is transferred to the equivalent force couple system. Whenever in given force system there are more than two forces, more than one force, F1, F2, then how to transfer? Then in that case we will first find the resultant of the given force system. How to find resultant? I will resolve all the inclined forces in horizontal and vertical component. I will find algebraic sum of horizontal and vertical forces, summation fx and summation fy, and I will use that summation of fx and fy to calculate my resultant r under r equal to under root of summation fx square plus summation fy square. And that r along with alpha I will find tan inverse mod of summation fy divided by summation fx. I will get the alpha from sine positive negativity of the summation fx and fy. I can show the resultant in quadrant in which it is acting. That quadrant is also required. If number of forces are acting, then after finding the resultant, transfer that resultant to a desired point with same magnitude and direction. First step is same. If single force is there, transfer that single force. If multiple forces are acting on that object, then first calculate the resultant of the force system, and after calculation of the magnitude and direction, transfer that resultant to the desired point with same magnitude and direction. In that case, if there are three forces F1, F3, F4, and I have to transfer, then I will transfer the resultant R with magnitude and direction alpha. In second step, I will calculate the moment about point B. I will calculate the summation of moment about point B of due to the all forces F1, F2, F3. If it as we have seen in numericals. After calculation of the moment at point P, show that moment as a couple to the desired point. Means here I will write moment MB. Then the given force system is converted into equivalent force couple system. I will repeat the steps to obtain the force couple system. If single force is given in the force system, then transfer that single force with magnitude and direction to the desired point where we have to obtain force couple system. Directly we have to transfer with same magnitude and direction to a desired point. But when forces are more than one, number of forces are acting, first we have to find the resultant of the force system in magnitude and direction. After finding the resultant, I will transfer that resultant with magnitude to the desired point. Very simple. If single force is given, directly transfer it. If number of forces are active, first to find the resultant, and after finding the resultant, transfer it to the desired point. Very simple. First step is over. In second step, calculate the moment of first force system about desired point. Means if my desired point is B, then I will calculate the moment about point B. Moment calculation, you know that. In moment calculation, we have to calculate the moment due to each force. We have to consider the sign convention, anti-clockwise as positive, clockwise as negative. And algebraic sum we have to show along with the orientation. Orientation means if my moment comes with positive sign, means it has orientation of the anti-clockwise if moment is positive. And if value of magnitude of the moment is negative, then it means that the moment is clockwise. And same we have to show that moment as a couple at desired point. It is very simple. We will see the numerical in next video, and we will understand how to obtain the equivalent force couple system and other systems when force system is given and we have to obtain another force system with the help of the conditions of the equivalent force system. So we will stop it. I hope you are enjoying these video lectures. If you have some questions or query, you can mail me or drop a message via WhatsApp. Definitely I will